I can't stop laughing now. My partner got pissed off that I started recording when he was discussing a sex song that he's only just realised is a sex song. Anyway, on to Speckies. I just got the poke of disapproval. We'll start with all the parts have arrived. So we got the transistors, and we got the keyboard membrane. So we'll start with easy, low-hanging fruit first, and get the keyboard replaced because that's nice, easy. That's a guarantee that it's gonna work. And I've also tidied my desk a bit since last video because it's been over a week because the MPN transistors, or was it the PNP ones? One of the sets of transistors took like an absolute age to arrive here, and I don't know why. But now we can actually get... I was going to get on with it yesterday, but I was just too tired because we had a load of things to do in the evening. That ended up dragging out longer than expected. So by the time I got back, I was just like, yeah, I'm going to bed. I'm tired. I got work tomorrow. Although tomorrow is my last day of work for Christmas, and then I can stay up late all I want and get back into a shitty sleep schedule. Oh, look, we haven't seen this circuit board before. We'll put this bit to one side for now. And here's our Manji keyboard. We'll keep a thing on for what way round the keyboard goes. So that's the top. Because we got the thin one on the left and the fat one on the right. Fat one on the right, thin one on the left. So cool. We'll put that up there the right way round. I don't know if it's keyed or not. And then we need to undo the sticky stuff in this, which is a case of just spray IPA into the thing and let it peel. It's going to be very difficult to show on camera. Oh yeah, that's coming off nice and easy. Let that drizzle down there. It's very easy for it to bend, and we don't want to bend it. There we go. It's lovely jubbly. Might be worth putting these through the dishwasher or something because they look pretty manky. They're not the worst ever. I'll probably just go clean it in the clean it. Yeah, this is just thin aluminium. Yeah, so that's that can be exteriorly clean, but yeah, it's just basically rubber domes pressing on a thing. Still, it's a nicer feeling keyboard than a Mac butterfly key switch one. And then this just slides on out as part of it tears off. It's quite interesting, actually. The person who designed this definitely did a nice job. They really did a nice job putting it together. You can see the hand traces versus the computer traces. Right, let's get a bit of wanky rag to dry out the IPA where we don't want it. There's a million videos on how to do this online. But you can even see those raised spaces on the... Yes? So, back to the keyboard. Slots them in there. Oh, good, they're already going back to sticky. That's good, because I don't actually have any new tape. So the fact that's going back to sticky is good. Because I don't have replacements. Cool, I'm just going to pause while I just clean these last two bits off. So now everything's being cleaned. I used some IPA to allow me to dry the water off a bit easier. A little useful tip and trick is when you've got something wet, spray it in IPA and then dry it. Because the IPA will displace the water and it evaporates a lot faster than just plain water. Make sure that fits in the little seating bits I've just spotted. There's little posts that bind it in, but you can see the keyboard looks a lot better. Obviously, the wear, where the wear is, the wear is. There's not much can be done about that. Interesting. Unlike on the ZX81, we don't have it labelled rub out. We only have it labelled delete, like you'd normally expect. And then we use the original 1980s tape because I don't have any replacements for now. And that should hold it relatively in place, at least until I obtain some just whatever generic tape I can find as a replacement, but that'll do for now. And then we got new flex, that's done. The more tricky bit is the next bit, which is to do with the transistors that have failed. So we'll put that to one side. Grab our specky motherboard. Because last time we discovered the... I don't know if I recorded that bit. But I did some voltage measurements. That's it. We left it with the RAM had failed and I didn't actually do any investigation further. So I'll tell you what happened because there's not really a lot to say. But there's two transistors in here which generate a negative voltage and a positive voltage for the lower the lower 16K of memory. The other like rest of 16K or whatever takes just your standard 5 volt. It is actually it's a different type of RAM. It's a TMS Texas Instruments 4532 20 milliseconds, whereas this is the same RAM that is in the IBM 5150, which is the 4116. Don't have a clue what brand that is, don't recognize it. Probably going to be one of those unreliable brands that dies all the time. So if any of these are dead, I actually have working replacements. If any of these are dead, it's going to be an order in. But the computer won't boot without its lower 16K working. And for that, it needs to have the right voltages. And these are only really receiving about 2.5 volts on both buses. And all the indications point to the transistors. Now, luckily, when I was back at uni, I brought one of these handy-dandy transistor testers. And I also did some diode testing on these transistors, and they're both looking very dubious. So we're going to desolder them, one at a time, so we can put the right one in the right place, test it, and then stick in a new transistor for both transistors, and we will have a game plan. I've tested these, the new ones, and they all work. They're not fakes, although it's fake chips that tend to be more of a problem than fake transistors. It's exactly what's held up the Sinclair MK14 project, is I cannot get a processor that's not from China. I do not trust vintage processors from China, because there are way too many fakes out there. And I cannot be asked to go through the hassle of having to claim back from China. So we discover that that was being held in by a ghost or something, because we removed our singular screw, and we shall start the process of removing TR5, and I think the other one's TR4. It's these two. They're responsible for generating the lower RAM voltages. This one also has a bit of a bodge going on, so we have to work around that, so that's going to be fun. Let's turn on the soldering iron. This one is the ZX213. Yeah, these were the ones that took forever to arrive. I'm going to pull one of these out. These transistors are also quite expensive, and I didn't have much luck trying to find alternatives. So if anyone knows any alternative transistors that can be used to the ZTX series, I didn't find anything, please do let me know, because then we can make sure that information's a little more out there for those who need it. And then we'll get one of these out. It was £5 for like 5 of these and £5 for like 2 of these. It's kind of ridiculous money for what should be a part that costs pennies a piece. But because they're obsolete, you can't get them on like RS components and stuff. Believe me, I looked. Especially when I saw the eBay prices. But eBay prices were the only option. So alternatives are definitely needed to the those. So that is a ZTX 213. That is 213 is the cheaper of the two. That is the this one. ZTX 213. That's going to be the first one we replace, and the label side is facing towards the rest of the board. That's an important factor. Right, cool. This is the part where you watch me burn my fingers and have a giggle. Actually, let's get something that'll be very useful for this. I have one of these things. It's quite a useful tool. Let's actually give it some more. This bloody solder does not like to roll out the thing very well. Because it's always easier to solder to fresh solder than old solder. Oh yeah, that did something. Ouchies! Right, where is this still stuck in? Looks like that pin. Ow! Remember, use pliers. There we go. Bit of solder landed on me. And then I'll do the same process for the other one, so I won't bother filming it, the removal of it. Well, we'll do this one first. We'll do this one all on camera, and then the other one we won't. No, don't solder the... This is double-holed solder, so it's probably going to be a bit of a pain to desolder. Oh, that came through. That's doing it. I can see the solder going into the wick. That's done. One more hole. That's doing nothing. It's kind of ironic you have to add solder to remove solder. But the solder actually helps with the heat spread, so that's why. Then you just wait for it to stop moving up the wick, and boom, we have 3 holes free. Ooh, that burn hurt. So the old one went over here. So we will position our transistor tester here. So that's the 213, which is this one. I always do it like this. So this is what it should measure: red, green, and blue. PNP silicon transistor. Collector and base emitter. That, and of course leakage current. You never want leakage on transistors. Let's measure the bad transistor. If this doesn't fix it, this is going to make me sad, because there's not a lot of other things that can go wrong. Then test this one, and we get PNP silicon transistor. Oh, this is not good. Collector, base emitter. Okay, cool. That's fine. That's fine. That's fine. That's fine. Leakage current, none. So this transistor tests good. Cool. So we could pop him back in, but I'll pop in the vintage one and pop that in the parts pot, since it still works. So we'll pop in this one. Rotate it around.
It's not. We've turned it.
Remember which way round it goes? It goes, the label's facing into the board.
It's meant to be an outdoor light.
And then it's your standard transistor soldering jobby.
Doesn't specify.
Then we grab snips of my various flavour that were actually available. I always find it's good to hold on to these because they can fly across the room and try and hit you in the eye. Can you check if that's my car alarm? No, it's not. Because mine is a horn, I do know that.
Your lights aren't flashing and neither are mine.
Cool, we're good. Yes, not your. Doesn't sound like your horn. Cool, okay, so I'm going to leave the desoldering of the next one and all that to the off camera. So now we're ready to test this transistor, the one which has not come out too cleanly. If this is not the problem, it probably means it's the RAM that's brought the voltage down. Which means we'd essentially have a shorted RAM chip. Oh, god damn it, phone and your stupid... Oh, unknown faulty component. That's what we like to see. Unknown faulty component. It can't even identify what it is. So it's the MPN one, the expensive one that's died, basically. So yeah, we've got a faulty transistor. It wasn't both of them, it was one of them. So that is our 649, 649. And let's show what it should be. That's actually good, because that means we have a chance of actually seeing this thing boot into the specky screen. This would be a good time to actually have some specky software to test on it, but I don't. Boom, and then we should have MPN. Yep, MPN silicon transistor, collector, base, emitter. Then you've got your usual sort of values you see on a transistor.
Right.
And of course, leakage current 0. Oh, Mouse has joined the Discord chat. We should angle the camera down so everyone can see what I'm doing. And it turns out my camera's not even on, so that was a waste of time. Anyway. It went this way round, didn't it? Yes, they're facing each other. I did not pay attention to what way round it's supposed to go in. That could be a thing that bites me in the ass, maybe. Maybe not. We'll see. This is not in the best place ever for going into holes. And that confirms it. I got it going in the right way around. Whee! Bend that out.
No.
Spread the legs. Let the soldering iron heat up. These pine seals are actually pretty decent. Makes a good little bench. Makes a good little
nice.
have at the computer soldering iron. Pop that in. No, do not short. I see what you're trying to do.
Just a reminder, don't put eggs in it.
Eggs. Yummy. Right, no shorts, no shorts. Good. Nice, yummy eggs Benedict. So the transistor that got abused is a dead one. Okay, I'm going to pause, reassemble this to a state I can measure voltages, and then come back. And recording. And smoke test! Cool, that's working. I can hear that power supply. So we should have 4 volts. 12 volts. 5 volts. Cool. So that's receiving all the voltages it should now. Right, let's plug in the little crappy CRT TV. I don't mind the noise that power supply is making. Oh, I forgot it did that. That was buggered. Is that the one that's 30?
No.
Oh wait, that's Glasgow. 30 average because they're sadists.